Guys, this is Mr. Millings, and in this video we are going to be doing some enthalpy calculations. So let's take a look at an example problem. Example problem, we are asked to determine the amount of heat that is associated with 1.26 times 10 to the fourth grams of ammonia being produced according to the reaction below. So we have a chemical reaction equation here, and what this chemical reaction equation is telling us is that 1 mole of nitrogen gas is going to react with 3 moles of hydrogen gas, and this is going to produce 2 moles of ammonia gas. And when this happens, using these quantities here, 1 mole of nitrogen, 3 moles of hydrogen, producing 2 moles of ammonia, 92.6 kilojoules of energy in the form of heat is going to be released. This little negative sign here means that energy or heat is going to end up being released by the chemical reaction. So that's what's going on right here. However, in this problem here, if we take a close look, it tells us that we don't have 2 moles of ammonia gas being produced. Instead, we have 1.26 times 10 to the fourth grams of ammonia gas that is being produced. And based on this quantity here, we need to figure out how much energy or heat or enthalpy is going to be released during the chemical reaction. So in this problem here, we are starting off with 1.26 times 10 to the fourth grams of ammonia. And based on this information that we're given in the problem, somehow we need to determine how much heat in kilojoules is going to be released. So if we have 1.26 times 10 to the fourth grams of ammonia, the very first thing we have to do is convert the grams of ammonia to moles of ammonia. So we know that 1 mole of ammonia, or NH3, is 17.04 grams of NH3. And if you're wondering where we got this 17.04 from, well, that's the molar mass of ammonia. We took nitrogen's molar mass from the periodic table of elements, which is 14.01 grams per mole. And then what we did is we took 3 times the molar mass of hydrogen, which is 1.01 from the periodic table of elements. This gives us 3.03 grams per mole. And then we simply added this value and we added this value together to get our molar mass of ammonia. So if we take a look now, the grams of ammonia is going to cancel with this grams of ammonia, leaving us with moles of ammonia. However, we want to know how much energy or heat in kilojoules is going to be released during this chemical reaction. So we have to take it a step further. If we take a look at our chemical reaction equation here, what this is telling us is that for every 2 moles of ammonia, this much energy is going to be released. 92.6 kilojoules of energy is going to be released. However, make sure that you put a negative sign in your calculation. Since energy is released, the sign of enthalpy needs to be negative. This negative sign, once again, just means that energy in the form of heat is released. So we have moles of ammonia on top and bottom that will now cancel. This will end up leaving us with kilojoules as the final unit of measurement, which is a measurement of energy or heat or enthalpy. So now all we do is we get our calculator out and we take 1.26 times 10 to the fourth. We then divide by 17.04. We then multiply by negative 92.6. We then divide by 2. And this should leave us with an answer of negative 3.42 times 10 to the fourth kilojoules, which is going to be the same thing as negative 34,200 kilojoules of energy that is going to be released by this chemical reaction, provided we have 1.26 times 10 to the fourth grams of ammonia being produced. So if you like what you see, go ahead and click that little bomb in the right hand corner, and that will subscribe you to my channel. And I hope you guys found this helpful.